All right, good morning, or third block. I am going, remember, or I guess hope I put it in the video yesterday since nobody joined me, that I would be gone today. I've got to take my daughter to her yearly checkup. I might be back in time to be online, but I wanted to make sure that I did have something posted. And part of, if you look in Canvas for tomorrow, or for, I guess, Tuesday and Wednesday, which I didn't put a Thursday up here, so I figured you guys would be dealing with that as are dealing with these same areas on today as well. Um, Yesterday or Wednesday, I talked about some bonding, how to identify ionic and covalent bonding. And today I want to look at the oxidation numbers and Lewis dot structures. Um, just a reminder while we're looking at this page, if you are absent and you do not come on to Google Meets, you have to do the makeup assignment. Friday is a teacher workday, no new assignments. You need to catch up on anything in this unit that we started Friday, October 9th. So anything in bonding unit. Anything before this, I need turned in today, Thursday. If it's not turned in Thursday, today, I cannot get grades in on Friday. So you've got to have it in or you get the grade that is there. So I've allowed makeup stuff. I've allowed you to have time and more time and more time. So I need the work in. It's got to be in. So I'm going to go and explain oxidation numbers and Lewis dot structures. The videos also talk about it, but I wanted to take a chance to go or some time to go over this. So you're going to need your periodic table. So those that I have a link to this back in the atomic structure module. You can, if you have a printer at home, and you can print, and especially if it's wireless, you should be able to print to it. Print out the periodic table if it helps you. Otherwise, you're going to have to always have that file open. So here's one, and I know it's a little hard to see, but there should be numbers, group numbers. And so on this one, you're going to have up here, you're going to have numbers 1 each column through 18. Then underneath it, you're going to have Roman numeral 1A, Roman numeral 2A, Roman numeral 3A. This is Roman numeral 4A, 5A, 6A, 7A, and Roman numeral 8A. All right, those are the numbers that you're going to need for what we're going to do. All right, so those tell you the valence electrons, and they're also the numbers we're going to use to figure out charge for elements or for atoms. So I'm going to change colors. Group 1, we talked about yesterday. Group 1 is your most reactive metals. So that's Roman numeral 1A. They are going to have a positive oxidation, a positive charge. They have one electron in their outer energy shell. So if I take lithium and I do a Lewis or a Bohr model, so it is in period 2, it's underneath hydrogen, so it has 2 rings. It has 2 electrons on the first. If you did the Bohr model activity, there are 2 electrons only on that first energy level. Lithium has 3 because it has atomic number 3. There's one left here. It wants to give away that electron. If it gives it away, it no longer has 3 electrons and 3 protons. It now has 2 electrons. So it has, if you do your math, a positive 3 and a negative 2 combined gives you a positive 1. So that's how they're calculating the 1, but it happens to match the group number. So if it's a metal, it's going to be positive, and it's going to be positive the group number. Okay? So the second column here then would be plus 2. This third column here would be plus 3. We don't do a lot with the fourth column. The fourth column is combination of metalloids and nonmetals. They can actually be positive or negative. We tend to deal more with them in the negative sense in that they share electrons. So we kind of skip this, but they can be plus or minus 4, because some of them in here will behave like metals and some will behave like nonmetals. Carbon is more of a nonmetal, or is a nonmetal. If you go down here, you've got tin and you've got lead and so forth, and they would be positives because they would be metals. But that group operates a little differently. So we don't use as many of those when we're dealing with oxidation numbers. Then you have your other columns here. So the next column is 7 or 5. It's not going to be minus 5. It has 5 electrons. How many more does it need to get to 8? Well, 8 minus 5 is 3. So it'd be minus 3 here. Um, this is 6. How many more to get to 8? Minus 2. How many more to get 7? How many more to get to 8? Minus 1. So let's look at a Bohr model of, say, nitrogen, oxygen, and fluorine. And so nitrogen has 5, oxygen 6. Nit, nit, nitrogen is 7, oxygen is 8, and fluorine is 9. So oxygen has 8 protons. 8 protons. So 8 pluses and 8 minuses. So if I start out, there's the nucleus, 2 here, 3, 4, 5, 6, 7, 8. Notice it has room right here and right here for 2 more electrons. If it is given those 2 electrons from another element, it will no longer have a negative 8. It would have a negative 10. And if I did the math, that would be negative 2. Or you can think of it, 2 more electrons is 2 more negative charges. So its oxidation is a negative 2. So let's look at nitrogen. Nitrogen has 7 protons and 7 electrons. So that means 1, 2. That means they're going to have 5 up here. 1, 2, 3, 4, 5. It has room for 3 more. That's why its charge is negative 3. It can, if it accepts 3 more, that makes it 10 minus. So do the math. It's a minus 3 for the charge. All right, so that's how we get the charge. You can always do it this way. What I like to do is on my periodic table, I will write the charges on top of those columns. Now, again, um, let me see if I can clear. Nope, that's a sticky note. I was going to try to clear everything, but okay. Um, so again, on your periodic table, let me erase this. For your charges, and this is going to become very much handy, important for what we're going to do next when we look specifically at how elements make compounds. We're going to look specifically at how ionic bonds form, specifically at how covalent bonds form. Now, metals in here, they form metallic bonds and they do something even more interesting, and that would be more at the chemistry level. We're just doing sort of an intro here in physical science. These transition elements, if they bond with each other to make, a nickel, there's a lot of electron sharing going on in there, and it's just, we call it a metallic bond. But a lot of these transition elements, these in here, usually have more than one charge. And so we're going to look specifically at what these look like. In one of the videos, they talk a little bit about it, but we'll look a little bit more into it. But again, this is a more advanced concept here that you will deal with in chemistry later. So let's go back and see what you're supposed to do. You're supposed to watch the videos on finding oxidation numbers. Oh, Lewis dot elements. Glad I went back. Let's look at that. So valence electrons, remember, were the group numbers. So let's take oxygen. Oxygen was in group 6 on the periodic table. So it was in Roman numeral 6A. So it's going to have 6 valence electrons. So here's the symbol O, and we take this and we start here, and I balance them out. These are electrons. This is 4. And then I start back 5, 6. So Lewis dot structures, and there's a whole video on this, just show valence electrons. We're going to use this in learning or seeing how atoms are bonding. Let's take beryllium, Be. It is in group 2A, so it has 2 valence electrons. Now, hydrogen and helium are unique. They only have one energy level, and the first energy level only holds 2. So hydrogen would be with just 1 dot, helium would be with 2 dots, but it's considered full because its outermost energy level is full because it can only hold 2. So those are kind of unique ones here. Hydrogen and helium can only hold up to 2 electrons. Helium is stable. So you're going to be practicing with this because in our lessons next week, we're going to be looking at how those compounds form. So again, I will add this video here. I may even put a little assignment to go along with the video. Remember, all work is due to Thursday, and Friday's a teacher work day. Nothing new will be up, but you need to catch up on anything that you've got missing in this unit for the second 9 weeks. You've got to pass the science classes in order to graduate. So you have to have a passing grade in biology, physical science, and earth science. So you have to pass this class to graduate. So if you're looking to graduate this year or next year, you've got to have this class. So if you did not do well this first 9 weeks, you need to make sure you're doing everything this 9 weeks. Remember, you can email me. I'll get to you as soon as I get back home tomorrow. If you want to set up an individual time, that will be great. I'll try to be on tomorrow afternoon at our old times at 1:30 and 2, just in case somebody needs to pop on and ask any questions. But the lesson is here on the online, or will be for tomorrow. I guess I will.